Okay, now today's question is swap nodes. You're able to see my screen? Everything is fine now? Hello.
It's visible.
Okay. Okay. I guess yesterday we discussed about this linked list approach and I said two things, right? One is fast and slow pattern, another one is simulation. Now, today we have two questions. I guess we have one question swap nodes in pairs. Yes, so this one. And basically, what question is they are saying is they have given a linked list. It's like pair them 1 to 2, 3 to 4, just swap them and again attach it properly. Just if you swap 1 comma 2, you'll get 2 comma 1. If you swap if you swap 3 comma 4, you will get 4 comma 3 and you should return this linked list. Question is fine for everyone. I can't see the reactions I guess today because so if you unmute and speak then it would be good for some question is fine.
Yes, sir.
Okay, that. See now actually see my main aim is kind of teaching most probably as much as I can. I'll teach the new patterns daily, not daily, whenever I get to know, because it depends on the question what they're asking. So today's question we can do it with simulation. Okay, just do dry run and you'll get it through simulation. So what I thought is I thought of teaching you recursion today. There is something known as recursion leap of faith. Just trust recursion, it will take care of everything. But the thing with the recursion is just believe recursion and it will do whatever everything it can be done. Okay. Now thing is just do the small thing you can do. Then just believe recursion. It will do the rest and give it to you. It's like there is one friend for you who can do the hard work and will make when we are in a team presentation also. One of them most probably will do the presentation and other one will do the whole project. One but remaining all will kind of working in Canva or easy works presentation, video making, editing, these all things will be taken care by some people, which is easy, but whole project will be done by some other people. The same thing. How we are believing them in the project context, the same thing now also we should believe recursion. But the thing is, they also expect you to do small things. So the recursion will also expect like, bro, you do small thing for me, and remaining all the remaining thing I will give it to you. I will do it and I will give it to you. But small thing you should do so that I will get habituated what to do. Very simple. It's like a tutorial we are showing for recursion that this small thing I will show how to do. So the remaining big problem, recursion will do it and give it for you. Is it clear what do you remember recursion leap of faith? Anyone? Yes, today I can't see the reaction, so I want you to talk, please. I thought to discuss another problem.
Yes, sir. Yes,
Okay.
sir. Yes.
Okay. So recursion leap of faith means I recursion wants us to do the small thing and it will take care of all the remaining thing. How far it is or how big it is, we don't care. The small thing we should do. In this question, see, in the worst case, if the size is 1, we can't swap anything. We will return the same thing. So there we are not doing anything. In this question, the smallest problem you can ever solve is when you have two nodes and we need to swap them. Okay. So for example, we have 1 comma 2 is given in the question. The output should be, if they give only 1 comma 2, the output will be what? What is the output, guys?
2 comma 1.
2 comma 1. This is the smallest problem you can ever solve it, yes or no? At least you will write some code. Otherwise, you will type directly return.
Yes, sir.
Yeah. So this small thing will be done by us and remaining big thing will be taken care by the recursion. Recursion means what? First of all, what is recursion? Calling, like there will be one function, like for suppose there is a function in swap nodes and we are calling the same function with some other way, same variable, but we'll update this thing and we'll send it to the back to the same function. That is recursion. Very simple. Calling itself. In recursion, there are 2 to 3 steps. First thing is base case. When we keep on calling itself, somehow it should terminate somewhere, right? That is where this base case will comes into the picture. Clear with the recursion base case. And this recursive step is there. This is called recursive step. What is recursive step? When we are calling the same function again with some updation value, that is recursive step. And this return, I will explain each and everything, no worries about that. So, did you understand the smallest thing we should do in this question is with two nodes, and we'll slab with 2, 1 and we'll return. Okay. Now, we will do with this question, what to do and everything. Okay. I will explain this. See now, this is the question given. Now, I will make a recursion leap of faith. That is very simple. I will do solve for this one, and remaining answer, the updated answer will be given to me by recursion. What is the updated answer? 3, 4 is there. So after, like normally we should swap 3 and 4, right? So 4 and 3 will be given by recursion itself. We don't need to solve. For suppose 5 and 6 is there next to it, then 4, 3, 6, 5 will be given by the recursion itself. We don't need to solve because we are believing recursion leap of faith. That's all. So I will solve this one, and I will expect recursion to give these all things, and it will give properly. No worries about that. Making sure that this logic is fine. The small question we are writing, if that logic is fine, then the recursion will do the remaining one, it will give it to you, no worries at all. Did you understand till now?
Yes.
Okay, okay, done. Now see, now I am thinking that I have only these two nodes. Okay. Now what I should do, I should swap them. Okay, okay, now I guess I have only these two nodes. Okay, now see what I will do. Here head is 1, yes or no? These two steps are clear. Head is 1 and head dot next equal to 2. Yes?
Yeah.
Yeah. Now, sir. Now, very simple. Now, our, kind of what we want from this one? 2, 1, yes or no? Yes? This is the output we are expecting for the smaller problem. We should swap it, yes or no? Hmm? Anyone? Okay. This is head dot next. What we want from this one? What can we say after this? See, this is the output we wanted for now for the smaller input. So now what I will do is, see, head dot next is 2 dot next equal to head. Did you understand this statement? Head is this one. Head dot next is this one. We want head dot next. Ka next should be 1. 1 is what head. So I am writing this one. Is it fine or not? Then we'll get this one.
Yes.
Till
Yes,
now it's
sir.
fine. Now see. Now I said recursion leap of faith, yes or no? So once we are done with this one single step, then recursion will, this step we have done it. Recursion will make sure that it is returning 4, 3 to us, and we should catch it near 1, yes or no? We should write key head. What is head right now? 1. Uska next, whatever recursion is coming, I should write. Yes or no? Did you get it, or shall I once again explain
Yeah.
it? Okay. 2, 1 we have done, and we are expecting recursion to do the remaining work, and that should get attached to 1. Yes or no? The same thing. Yes, very simple. 1 is there as our head, and we are expecting recursion to do the remaining work and get attached to 1. What is 1 in our case? Head. So first of all, I am preserving the next node. I will say what it is, how, like why we are doing that. Let it as temp. Now head dot next. Head dot next is the recursion. Now rather, why are you sending head dot next to the next recursive you call? Why? See, now we have 1, 2. We have solved the problem for 1, 2. Next, recursion will make sure that it will solving the all remaining problems. So if it wants to do, if we pass head dot next, then it will be 2. Then it will swap 2 and 3 and give it to us. No, what we want, it's like for every two nodes we should swap, and again for every 2 nodes we should swap. Yes or no? That's why I'm passing head dot next dot next. Did you get it? Why I'm
Yeah.
sending this one. Okay. Now, see, this one I will let you know why I'm doing that. When we dry run, then we will understand why we are writing this step. But this step is clear for everyone. Head dot next
Yeah.
equal. Now, once we got this one, right? Now we got head dot next equal to, and this one we got. And we preserved already two node. 2, 3, 4 I already preserved. Yes or no? 2, 3, 4. See, I said for you about linked list. If you catch two, you can get the whole 2, 3, 4. Because if you pull one, like when you're holding each other to everyone standing in a single line, if you pull one guy, everyone, everyone will get affected. Yes or no? That's why when I am carrying temp equal to head dot next, that means that I am carrying this 2, 3, 4. Okay? Is this clear?
Okay.
Did you get it? Like what I'm trying to say is, now head is this one. Head dot next is this one. I am assigning temp to head dot next. Nothing but from 2 say I will have everything in my hand because they are holding each other. Linked list nothing but holding each other, right? So these all things will be in my hand in temp. Okay. Now what I want to do, I said recursion leap of faith. Recursion will do the remaining thing. But where it should get attached? Head dot next. Why head dot next? Because 2 comma 1 and remaining all things will be taken by the recursion. So head dot next should be the thing which recursion is getting for me. That's why I wrote head dot next equal to recursion head dot next dot next. Why head dot next not next? It's very simple because I am dealing with pairs right now. If I send head dot next to the recursion, then it will swap 3 and 2 and it will give it to me. But I don't want that. I want 4 and 3 and I want recursion 2 to swap and get 4 and 3 for me. Yes or no? And get attached to 1. That's why I'm sending head dot next dot next. Once you get from the recursion, what I will do is I already stored the temp. I will write temp dot next equal to head. So that I'm connecting this link. Did you get it now? Now
Yes.
see, I am sending
Yes.
head dot next dot next. Okay. Now head is this one and head dot next is 2. Head dot next is 3. Yes or no? So for next recursion call, this 3 will be there. Okay. Now this is the next recursion call. Okay. Now what I will take in two nodes are there, right? I have only two nodes because I will take care of the small things only. So like this will be taken care by the recursion, but I'm explaining you how internally it works. Head dot next dot next. It will go again call this function. It will call with 3. This one. Is head equal to null? No. Head dot next equal to null? No. We have 4 bro. So it's not null. So this condition is never in. Like for now this is not there. Now no temp equal to head dot next. So I will carry this temp and I will keep it at 4. Okay. Now head dot next. What is head dot next? 3 dot next equal to swap nodes of something. Yes or no? Did you understand what I'm trying to say? Hello.
Not this part.
Okay, wait. What I'm trying to say, see, now what we have done for 1 comma 2, I will do the same thing for 3 comma 4. Actually, this can be done by recursion itself, but I am explaining you how recursion works internally. Okay, now see, 3 comma 4 is there. No temp equal to head dot next. I kept temp over here. Whatever comes next to it also will be handled taken care by temp. Till now it's fine. This step.
Yeah.
Now head dot next equal to like this 3 dot next equal to I will call another function and I will make sure that that is taken care by the recursion. I am sending head dot next dot next. Head dot next is 4. 4 dot next is null. So this condition will come if head equal to null, return head means return null. So we get here null. I will get null and it attached to it because why it is getting attached, null is getting attached. Head dot next equal to swap nodes. Head is what? 3. 3 dot next is the whatever got by the recursion. What recursion is getting for me? Null. So I got it for null. Done? Understood?
Okay. Yeah.
Now one job is done. Ki we swap, kind of swapped and we are making sure that recursion got terminated because we got a null. Now one more thing is left. What is that? Connecting these two and sending these three to one. Yes or no? When we did work for our 2 comma 1 or 1 comma 2, we made sure that recursion is getting for this one, right? This how we are getting by recursion I explained you right now. Temp is this one 4. 4 dot next equal to head. So it will be connected here. And return temp. What is temp 4? Return. Return it where? Where it called? Where it called? Here. At 1 it called function. Yes or no? That's why it will call return to it here and it will get attached to it. Did you understand why I'm preserving temp? Because we lose it pehle. We are doing head dot next equal to. We are getting this one. Normally, after head we have 2. But we need 2 because after swapping we should keep this as head right. Very simple. See, I already said we care only about small problem. If this is the case, only we have 1 comma 2 as an linked list as an input. We will make sure 2 comma 1 is output and we will return head. Every time we will return the head of a linked list because they all are interconnected. If we return one node, everything in the linked list will be coming there. Yes or no? That's why I should return 2. What is 2 here? Temp only, right? Head dot next equal to temp. 2 is temp only, right? That's why I'm returning temp. No worries at all. No need to think much. Return temp. Why I'm writing return temp? Because I want to return 2. 2 is in my temp. Did you understand why I'm returning temp? I know this is a hard pill to swallow, but I understand. But I'm trying to explain how recursion works at least. We can do this via simulation also, but 3-4 kind of things needed. That we can do.
Explain explain temp one again.
Okay, see,
How
you
temp
don't
one
mute
stores
yourself.
the first one.
You don't mute yourself. See, 1 comma
Okay.
2 is there. Temp is head dot
Uh,
next. Yes or no? Temp I am storing as 2. Yes or no?
okay.
Now, after swapping, I want 2 to return to the function. Yes or no? Head will return every time
Okay.
for the linked list. Now 2 is what here? Temp only, right? Head dot next.
Yes.
So that's why I'm returning temp.
That is okay for only 1 and 2. If 1, 2, 3, 4 is there, then
1,
the
2, 3, 4
temp
is
goes
there.
to 3 and
See,
4.
now 3 and
Huh.
4 for another recursion call will happen because head dot next dot next.
Huh.
Now 3,
That
4 will
time
come.
temp will be
See,
3.
no, they got head will be 3. We are getting
Okay.
head here. Head dot next. Here head is there. Head dot next is 2. Head dot next is 3. So we are getting doing recursive call for 3. Now, if head equal to null, no. Head dot next equal to null, no. So this condition never, now it's false. No temp equal to head dot next. Head dot next is what now? 4, right? Because head is 3 right now.
Okay.
And we should return 4 only here. Yes or no? To the function. To the one.
Yes.
What I said, this is recursion, take care of everything. Recursion, what should return? It should return 4 only. What is 4 in our case? Temp only, right? That's why I'm returning temp.
Oh, this is not the main return type, na?
This is return type only. They're asking her to return the node type.
Okay.
Like you didn't understand what I'm trying to say. The thing is, no need to think about remaining thing. Just think about having input 1 comma 2. That's all. Then you will return temp only, right? Yes or no? That you understood?
Yeah.
So the same thing, while recursion is doing, recursion will think like only 3 and 4 is there and do one send it for you. And again 5, 6 are there means it will do one for 5, 6 and thinking that only 5, 6 exists in the linked list. It will swap it and return the 6 for you. The same things happen recursively.
Okay.
Everyone everyone understood 1 minute. I am coming to meet. Now I can see everything, like your reactions and everything. What do you feel now? Everyone? Harish, you understood properly? Arpita, Hemang, Prakar, everyone. Harish,
Yes.
everything proper, right? Each and every step in the recursion, because it's very, very important. That's why I'm trying to explain. I know, it's kind of hard to swallow this pill, this recursion pill, because it will take a lot of time. I know, but in linked list also we can use recursion. That's what I wanted to show for you. Recursion is kind of a topic where you can use anywhere. Whenever you have redundant work to do each and every time, then we'll use recursion. Here, 1 minute, someone, just a second, someone is trying to say something. Radhakrishna, believe. Okay, so that's what I'm trying to say. Just, these two things will be taken care by us. These will be coming from the recursion, and we'll swap this one, and we'll keep, like, believe recursion, and recursion will get it for us. This question properly understood by everyone. Everyone is fine with this approach, right? Arpita, did you understand? Okay.
Yeah, understood.
Yeah. Okay. Why we are sending head dot next, why we are attaching head dot next equal to this one, why we are taking, first of all, why are you taking temp, each and everything you should understand properly. Why we are we taking temp? Because we are preserving the second node. Because once we do head dot next equal to recursive call, we will lose that node too. Yes or no? We should preserve it before itself. That's why I wrote node temp equal to head dot next pehle first. Then I did the recursion call. Once I am done with the recursion, then I will attach this one to the two. Here, temp dot next equal head. I will try to write the same code in lead code, I guess. Lead code. What is this one? Swap. I don't know. I guess I would have done it before, but I guess it's all okay. See now. I will write the code. Most probably same code only. See. Head equal to null. This is base case. Always for remember the in first thing in recursion you should write base case. I can write two base case like see if head equal to null, return head. So return null. If head dot next equal to null, nothing but only one node is there with me, then I should return head only, right? Yes or no? See here. If I don't have anything, I will return nothing. If I have only one node, I will return that only. That's why these both can be written simultaneously with this condition. Are you sure with this one? Anyone respond? Head dot equal to null or head dot next equal to null. Return head itself. In this case, head will be null, and in this case only one node will be there in the head. You understood this point, everyone? This is known as base case. Rather, why did we return head? Why did we return null? Because null is the ending point of the linked list. That's why I return null. Now see, preserving next node. So I will be like this node temp equal to head dot. First of all, I am reserving it. Now recursion leap of faith. What? Okay, head dot next equal to recursion. I already did the things which should be done for my small input. Now you do for the alternate head dot next. Once you are done with your work, I will make sure that the temp dot next equal to head. And as 1 comma 2 is there, I should return 2. What is 2? Temp. That's why I'm returning temp. Don't overcomplicate what to return, what to write, when to write. Very simple. Take a small sum, whatever you can do. Just write the code for that one. In between, add recursion. That's all. Nothing else to be done. See now, the return type is list node. Nothing but I am returning a node. That's why when this functions return a node, I am catching it through head dot next. Head dot next is also a node. Yes or no? That's why I'm writing head dot next. I can't write here key int something node or something. I can't read because this is expecting a int value from this function, but actually we are sending list node from this function. So we should do something here. Did you understand everyone? Like I can't see your Google Meet minimized version, so I want you to talk. This is a problem with the lead code. Like, that's a take. It's not. Okay, don't believe this 100% beats. Okay, it depends on the, it's like on the lead code algo, it's like that. Just see your time complexity and everything. Often, yes or no? Only I am iterating often, but when you use recursion, it will use stack space, extra stack space, so it will take space of complexity also often. But when you do in a iterative way, like simulation based, then we don't need space complexity. So I am not saying this is optimal solution. I am just letting you know that we can solve through via recursion, and I explained you how recursion works. What is recursion? The same simple thing. Calling itself with different kind of updated value or something, and it should terminate somehow. So we are writing here the terminal base condition, and what we are returning. This function is expecting a type node. Though that's why I will return node only. I can't return like something int, I return 0. Those all I can't return. These all I can't return. I will return temp only because that is the data type of the thing which it is accepting and it is expecting us to do. Now shall I go with the another question? Today's question is done. Once you send the link, try to the only suggestion I would like to give is you will listen the lecture, you will get something, it will go into your brain, at least something, not everything. I understand it is very hectic for you to know, very hard for you to also get everything into your head. So whatever you have done, try to code it and try to have a convo with the chat GPT, where I am lacking, why I am not able to understand this one, try to understandable in your way, then try to submit in the GCR. Okay, this is the main motive of it, of these videos or whatever I'm conducting everything, only because of that. Okay. And yesterday I said lead code has linked list has two patterns. One is kind of a fast and slow, and another is like kind of simulation. Yes or no? This we can do with the simulation. That's why this is kind of simulation only. Whatever they're asking, I am doing, but I am carrying recursion through it. That's all. Normally you can do an iterative way also. Some of them I had already done it, I know. So that's the thing. So I thought to discuss one more sum in slow and fast pointer today, and which is one of the most important question asked in the interviews or whatever. It is very good actually. Do you remember yesterday I said about that running race? Two people were running and in a circular loop. So circular race kind of track. If one guy is walking in the speed of x and another one is walking with the kind of 2x, the one who is walking with x speed, when he reached middle of like when he completed half of the track, the 2x speed guy would have completed a whole one circle, matlab one loop. Yes or no? Do you remember fast and slow approach? Yes, fast and slow. I guess I took example of Sakshi and me, because Sakshi is sprinter, something Vaishu and everything. Yes, let me go through that for 1 second and then we will come back here and I will solve that question also. Yeah, this one I guess. This is a loop. I will start here. Both of us will start from here. By the time I reach here, the opponent who is like running with 2x of my speed will be completing one loop. That is fast and slow. And I also said that rabbit and tortoise example also. Now this question. Cycle detection in a linked list. Okay. Now see. Same fast and slow pointer. Okay. Now sir. How slow? Like, can someone keep on saying where slow will go, where fast will be updated? Slow will be. Hello, Prakar, Tanay.
Can you repeat
Slow will be 38. Yes. Fast will be.
73.
Okay. Next.
Then slow will be 58.
Bro.
Oh no, 73.
73.
Sorry,
And fast will
73.
be here, because it is going like
80.
this. Okay.
Okay,
Slow
okay.
will be 58. Fast will
58
be
and
42.
fast 42.
Next, slow will be 89.
Will be
And fast
89.
will be 4.
Fast will be 4.
Slow will be 145. Fast will be
145
37.
and 37.
Slow will be 42. Fast will be 89.
Fast will 58.
58.
58, no?
Okay. It's
Yeah.
slow will be 20. Then fast will be this one.
Fast.
This will be this one.
Okay.
This will be this one. Somewhere it should meet. Why it's not?
It's going in a loop. No?
No. It will meet. Definitely it will meet. Just imagine, one guy is somehow they will intersect each other, right? When one guy is going 2x of speed and another guy is going with x
Yeah.
speed, by the time he reach middle, he would have completed the whole race. What that does that mean? Definitely they would have intersect one place, because the 2x guy
Yeah.
should cross the first guy. Yes or no?
Let's do again.
Okay, slow. Fast will be at 73. Slow will
Okay.
be at 73.
And
This will be at
They
89.
intersected.
Slow it will
Huh.
be 58. This will be at 42. Yes or no? Slow will
Yes,
be at
yes.
89. This will be at 4.
4.
Slow will be at 145. This will be at 37.
177.
This will be at 42. And this will be here.
89.
And this will be here. And this
20.
will be
42.
42.
42.
Now they
Now they
intersect.
are intersecting slow. And
Yeah. Fast.
this indicates that there is a loop in the cycle. Very simple. Rather, how can we say that when they meet cycle exist? If cycle doesn't exist, okay, then definitely they would have reached null somewhere. Yes or no? Like this one. Fast, slow, fast, slow, fast, slow. I guess we discussed in this middle of the linked list. While when we will terminate our thing, when the fast reaches null. Yes or no? When fast reaches null, we'll terminate the loop, thinking that we got the middle at the slow. Like it's like Vaishu has gone through null. Radha is at mid. Radha is slow. Vaishu is fast. Yes or no? The same thing. Now, one minute. Now, if see while fast not equal, I am thinking that this is gonna end somewhere else. Okay, somewhere it's gonna end. Thinking that cycle doesn't exist. I am initializing this one. Node fast equal to head and node slow equal to head. I am doing while fast not equal to null and fast dot not this I said for you, right? Why I am writing these two conditions on that day, previous day. One is for odd length and one is for even length. Yes or no? Yes.
Yes, right.
Fast equal to fast dot next clarified. Slow equal to slow dot next
Yes, Ram.
clarified. If fast equal to slow,
Yeah.
return true. If not, return false.
Yeah.
This matlab, no, it's very hard. If cycle doesn't exist, we can't even say that. That's why we'll keep on returning here. This condition never comes. Okay. If we are not able to return true, that mean that we are returning false only. Did you understand? We are returning true when it is cycle is formed. If not, then it will be false only. It will be taken care by the last written statement because this never comes. See, cycle doesn't exist means this doesn't come. Yes, because we won't encounter this if statement. That means somehow fast will reach null because it is a kind of straight linear kind of structure. No cycle is there. So that's why I'm returning false. We will terminate this loop, right? You understood? How can we get this one?
Yeah.
If cycle is there, we will keep on looping. Somewhere slow and fast will be equal. I will return true. If cycle is not there, let it be this link is not there, okay? Now what? After 37, there will be null only, right? Then fast not equal to null or fast dot text not equal to null. This condition will definitely hit it somewhere else. At some time, we will hit this condition and will come out of the loop and return false. Did you understand?
Yes, Ram.
Yeah.
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 So okay. Shall we write then? Node fast equal to head. Node slow equal to head. While fast not equal to null and fast dot next not equal to null. Fast equal to fast dot next slow equal to slow dot next. If slow equal to fast, return true. If not, return false. Everything is clear? Shall I run?
Yes, right.
Comparison completed. But I don't know what's gonna happen. But we'll try to solve it. Done. Okay. Did you understand this one? This detecting loop using this one is see the naive approach is using hash set also because see I'll explain this also so that you can get an intuition of hash set also. Now I'll be like see it's only 33 minutes, okay, that's why I'm trying to explain this approach also. Now I will start from here. No slow pointer, no fast pointer, just a temp. Okay, let me write the code of that also. While temp not equal to null, I am taking I guess you got it right. Temp is like oh. Okay, this I am initializing temp. Now I am writing this one. Now see, I am maintaining a hash set also. This will be a type of integer, right? Set equal to new hash. Aripta, you listen this hash set hashing lecture?
Yeah, I was there.
Okay. See now I will be like, I have seen 116, so I will add 116 here into my hash set. Okay. Now, okay, let me take one more thing from you guys. Okay, another issue. Okay, now see. Temp at 116. Have you seen 116 till now? No, I will add it to the hash set. Now I'll go more front. So that's what I'll write, okay? Now, if set dot contains already temp dot val or something. Temp dot val means, right? Linked list is a like, it will carry two things. One is data, another is the node pointer which is point to the next node. I am making sure that is val. Okay. This is fine. If set dot contains of, sorry. Okay, first of all, we'll fill this. Now temp will move before, after, then temp 38 have you seen in the hash set? No. Okay. Now you add. Okay. Now you add 38. Now go to next. 73. Have you seen 73? No. Add 73. Okay, next move.
Radha,
Oh yeah.
won't they meet at 73 also?
Yes. Sorry.
Like they are meeting at 73 also, no?
No, this is wrong picture. We'll start both from here only, right? Not this. You understood? Huh?
No,
No.
it
Where is fast and slow? Okay, wait, let me show. Fast will be here and slow also will be here. Not from
yeah,
here. So fast will be like
yeah,
this and slow will be like this.
yeah, and
Yeah. When will they meet?
like if slow moves first, it will go to 38,
Yeah. Then it will go. Fast will go to here.
and then slow will go to 73, na?
Yes, wait. Slow will go to here. Then afterward we wrote this line also, right? Okay, wait 1 minute. What I'm trying to understand. This tab, this function will work. No, okay.
They should meet at the same position in the same iteration, not separate iterations.
Yeah. Wait. I will explain him. Like very good doubt, but I will explain. See, Tanay, sorry. According to you, Prakar, I will first start the slow pointer, right?
Yeah,
First, slow. Okay, very simple. Now, first of all, slow will go front. Fast will go here. Yes. Next, slow
yeah.
will, now we will check if fast equal to slow. No, then go proceed again. Slow will be here. Now this step will be there, right? Fast equal to fast dot next dot next.
Oh,
Then we will check for
okay, okay.
return if it is there or not. Okay, got it?
Okay, got
Yeah,
it.
nice. Thank you. Temp right now we are at 73. Have you seen 73? We'll ask hash set because hash set is like a Doraemon only, a Doraemon kind of bag where we can see whether something exists or not within a go of one time, right? So 73 exists, no. Okay, add it into your bag for further purpose. Now I'll be at 58. Have you seen 58? No. Okay, then try to add 58 also into your bag. Then go for 90, 89. Have you seen? No. Try to add 89 also. Like this, we'll write add everything. Okay. Then next we'll go for 145. No. 42. No. 20. No. 4. No. 16. No. 37. No. When we go to 58, has said, did you see 58? Yes, I already had 58. This means that there is a cycle in the list. Because while we are iterating in a single loop, definitely we won't see. There is one more constraint that there is only distinct values in the linked list. Okay, if there are duplicates, then we might fall into trap. But that doesn't happen because thinking that there is contains only distinct elements in the list. Then if you are kind of mm, appearing a node twice, then what does that mean? We are in a so like slope. Yes or no? Did you understand?
Yeah.
The same thing. Yes.
So like if we assign indices to them and
No
like that
indices. No indices.
indices
This is
will
linked list.
okay, okay.
See, Prakar, I'm talking about two conditions. One, there are no duplicates in the list. Okay. Second,
Yeah.
that's why I'm comparing with the value. If they say that they have duplicate, then instead of storing an integer, I will store list node, which has a address to it. There might be duplicates, but the address might be different. Very simple. Prakar Goel, two people are there in our class. Then name might be fine or name might be same, but their everything, their character, like there are two different people, right? They belong to two different spaces. Yes or no? The same thing. That's why to identify that, I will have a list node. If they mention that there are no duplicates, then I will have integer only. Did you understand what I'm trying to say?
Yeah.
Every node has separate address, even though they have value in it as same, but this address might be for 38. They let it be like 38 has address as 100. Okay. Now there might be one more 38 here. This address will be 120, 130. Never it won't be 100 for sure. If it is for 100, then it should carry 7358 next to it, because address value is unique. Yes or no? That's why if they say that unique value, like the duplicate values are there, then I will write as list node. If they say nothing, then I will keep as integer. Fine with it? Yes or no?
Yeah.
Now if set dot contains of temp dot well, what that mean? Return true, because we had a cycle. Did you understand? If we don't have, then for further iteration you add temp dot val, and it will be useful for some other people. Yes or no? And temp equal to temp dot next. Did you understand this one, everyone? I will go on. Wait, let me come through meet. Harish, Arpita, Siddharth Malik, everyone, Balaji, everyone understood the hash set approach? Janvi, anyone has any? Yeah, Tani.
Can you repeat the if same duplicate elements are there for that one?
Okay, wait. I will say remaining all everything is fine. Everyone, Brinal.
Yes.
Okay, done. Janvi done. Hemang, I know it's the first day for you, so it's somehow difficult for you to, go through and understand this one, but try to understand later on. If you have any doubts, you can ask anyone or me also. It's totally left. Siddharth, is it fine?
Seems Siddharth is still eating his food.
ठीक है, मैं पहले कोड करता हूँ, उसके बाद तनय का थिंग आई विल राइट एक्सप्लेन. ओके ओके, everyone is fine with this approach, right? Predict a loop in linked list. I will see whether they have said anything about the duplicate things or not. You have given the head of the linked list, you have to determine whether a head given linked list contains a loop or not. A loop exists in the linked list if next point of last node. Initially, okay. See, they haven't mentioned anything. So that's why I will take the addressing part. That is safer part. Yes or no, Prakar? See, taking integer is kind of when we got a confirmation that we don't have any duplicate. If we have duplicate or not, it doesn't matter when we do with the node part. Yes or no? Did you understand why I'm writing this one?
Okay.
This is safer side.
Yeah.
Whatever it will work, right? Whether it has duplicates or it doesn't have duplicate, it will work. That's why I'm trying with the right this one. No
Yeah.
temp equal to head. Tanay, did you understand now? Or did I talk any? First of all, they say, see, what I'm trying to say is, wait, let me write it. Temp equal to temp dot next, because for every iteration, temp should update its value. Now, if set dot contains of temp, we will ask, does you like, do you carry this, already you had seen this value or this node? If yes, then we'll return true, because we can see a node twice if and only if there is a loop. Did you get that part? Why I'm trying, like why I'm, what I'm trying to say? Did you understand?
That is okay.
Okay.
I did not understand the first line. Has set node
Okay,
same.
there is one mistake in the code. Meanwhile, you say people, what is the mistake? Now see, Tanay, there are two
Okay.
Tanay Barnwal, okay? One is you and another is your
Yeah.
friend. Now if ma'am calls you Tanay Barnwal, both of you will raise hand because you don't know whom she is referring to. Yes or no?
Okay.
Now if she says that Tanay Barnwal who lives in West Bengal, then you will raise hand. Yes or
Uh,
no? It's like your address.
yes.
The same thing with the list linkedness. See, now this node is there, right? This has one address.
Yeah.
This has one
Okay.
address and this address will be
Uh,
storing to a next pointer. Yes or no? They do have a unique address, right? For suppose there are two,
okay.
three values in the linked list, it single linked list can't hold more than one address, right? So it should be holding only one. So definitely, if we are referring to address, then definitely, like that's the
So
best case we can do.
node is the address.
Yeah, node means we are carrying poorer. This is node. Data will be there, like our value, and node also
Okay,
will be
okay.
there.
Understood.
Yeah, that's why if you
I did
carry
not
through
got.
the
I did not understand the node part only. What is node?
yeah,
Okay.
no, somewhere yeah, okay. Guys, there is one mistake. First of all, say that. What is that mistake? Anyone? No, if you don't say, I won't continue.
Alright, go to the code.
Okay. There is some mistake in this code. Say for me. Anyone? I am declaring a hash set. I am assigning temp to the head. I am making sure that it's not equal to null. If it contains return true, update the next pointer. Return
Should
false.
add to the
Huh?
set. Should we add it to the set?
Yeah, exactly. Yes. Correct. Okay, yes. For suppose I am not adding this one, then it will never return true. It will definitely return false only every time because we are not adding to the set. Then every time it will return false, 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 false only. Some test case will fail, some will pass, and some will fail. See, fail. More than time limit exceeded because there is no end. That's why if I do this, then it will work. This is taking off end space, right? That's why. This is done. If the number start fluctuating, then it doesn't that mean that everything is gonna pass. So I am done with my questions. So if you have anything, first of all, wait.